So I have three different relationships here between x and y, and I want to think about which of these, if any, are proportional relationships. And then I want to graph them to see if we can see anything visually that makes them obviously proportional. And just as a reminder, a proportional relationship is one where the ratio between the two variables, and let's say we took the ratio between y and x, you could also go the other way around, the ratio between x and y, but the ratio between y and x is always going to be some number, some constant number. Or you could rewrite it another way. If you were to multiply both sides of this equation times x, you could say in a proportional relationship, y is always going to be equal to some constant times x. So with that out of the way, let's look at these three relationships. So this one over here, let me draw another column here. Another column. This is, let me call this the y over x column. I'm just going to keep figuring out what this ratio is for each of these pairs. So for this first pair, when x is 1, y is 1/2. So this ratio is 1/2 over 1. Well, 1/2 over 1 is just the same thing as 1/2. When x is 4, y is 2, this ratio is going to be 2 over 4, which is the same thing as 1/2. When x is -2 and y is -1, this ratio is -1 over -2, which is the same thing as 1/2. So for at least these 3 points that we've sampled from this relationship, it looks like the ratio between y and x is always 1/2. In this case, k would be 1/2. We could write y over x is always equal to 1/2, or at least for these 3 points that we've sampled, and we'll say, well, maybe it's always the case for this relationship between x and y. Or if you want to write it another way, you could write that y is equal to 1/2 x. Now let's graph this thing. Well, when x is 1, y is 1/2. When x is 4, y is 2. When x is -2, y is -1. I didn't put the marker for -1, but it would be right about there. And so if we say these 3 points are sampled on the entire relationship, and the entire relationship is y is equal to 1/2 x, well, the line that represents, or the set of all points that would represent the possible xy pairs, it would be a line. It would be a line that goes through the origin. Because look, if x is 0, 1/2 times 0 is going to be equal to y. And so let's think about some of the key characteristics. One, it is a line. This is a line here. It is a linear relationship, and it also goes through the origin. And it makes sense that it goes through an origin, because if in a proportional relationship, actually when you look over here, 0 over 0, that's indeterminate form, and then that gets a little bit strange. But when you look at this right over here, well, if x is 0 and you multiply it by some constant, y is going to need to be 0 as well. So for any proportional relationship, if you're including when x equals 0, then y would need to be equal to 0 as well. And so if you were to plot its graph, it would be a line that goes through the origin. It would be a line that goes through the origin. And so this is a proportional relationship, and its graph is represented by a line that goes through the origin. Now let's look at this one over here, this one in blue. So let's think about whether it is proportional. And we could do the same test by calculating the ratio between y and x. Y and x. So it's going to be, see, for this first one, it's going to be 3 over 1, which is just 3. That's going to be 5 over 2. 5 over 2. Well, 5 over 2 is not the same thing as 3. So already we know that this is not proportional. Not proportional. This is not we don't even have to look at this third point right over here, where if we took the ratio between y and x, it's -1 over -1, which would just be 1. But let's graph this just for fun to see what it looks like. When x is 1, y is 3. When x is 1, y is 3. When x is 2, y is 5. X is 2, y is 5. And when x is -1, y is -1. When x is -1, y is -1. I forgot to put the hash mark right there. It was right around there. And so if we said, okay, let's just give the benefit of doubt that maybe this is that these are 3 points from a line, because it looks like I can actually connect them with a line, then the line would look something like this. The line would look something like this. So notice, this is linear. This is a line right over here, but it does not go through the origin. So if you're just looking at a relationship visually, linear is good, but it needs to go through the origin as well for it to be a proportional relationship. And you see that right here. This is a linear relationship, or at least these three pairs could be sampled from a linear relationship, but the graph does not go through the origin. And we see here when we look at the ratio that it was indeed not proportional. So this is not proportional. Now let's look at this one over here. Let's look at what we have here. So I'll look at the ratios. Y over x. So for this first pair, 1 over 1, then we have 4 over 2. Well, we immediately see that we are not proportional. And then 9 over 3, it would be 3. So clearly this is not a constant number here. We don't always have the same value here. So this is also not proportional. Not proportional. But let's graph it just for fun. When x is 1, y is 1. When x is 2, y is 4. This actually looks like the graph of y is equal to x squared. When x is 3, y is 9. At least these 3 points are consistent with it. So 1, 3, 4, 5, 6, 7, 8, 9. So it's going to look something. And so if these points are sampled from y equals x squared, then when x is 0, y would be 0. So this one actually would go through the origin, but notice it's not a line. It's not a linear relationship. This right over here is the graph of y equals x squared. So this one also is not proportional. So once again, these 3 points could be sampled from y equals 1/2 x. These 3 points could be sampled from, let's see, y is equal to, let's see, it looks like a line when this looks like it could be y is equal to 2x plus 1. So it's a linear relationship, but it does not go through the origin, so it's not proportional. And these 3 points look like they could be sampled from y equals x squared, which goes through the origin. When x is 0, y is 0, but it's not a linear relationship. But any way you look at it, if you look at it visually, it has to be a line that goes through the origin, or if you look at a table of values, you just look at the ratios, and the ratios always have to be the same value. And that was only the case with this magenta one right over here.